This is a production made by students from the Master of Architecture course, Delft Seminars on Building Technology. In the Netherlands, most of the buildings have been designed with traditional masonry and concrete. These facades are fixed, but they have to withstand all the different weather conditions throughout the year. High summer temperatures that heat up a building are currently countered with mechanical cooling installations. With weather conditions such as rain and frost, the facade needs separate installations to make the inner climate comfortable. We, as a new generation of architects, strive to combine those into one active facade which will adjust itself to different weather conditions. We decided to implement this new concept in a redesign of the Rotterdam Maritiem Museum. This building was designed by Wim Quist and was completed in 1986 as the first Dutch maritime museum. It is situated in a district that lies in between the inner city and harbour. It is designed on a grid of about 100 square meters. The building is placed in the most northern corner of the site. It has the shape of an isosceles triangle. A square volume was then placed asymmetrically inside that triangle. In 2004, the successor of Quist, Frank Wintermans, added a second cubic volume in a restoration project. Due to underground pipelines and electricity cables, the original design had to implement arcades in the facades facing the streets. This resulted in the following floor plan. Analysis of the building showed that the facades of the latest added volume were best suited for integrating the active facade concept. These facades are best suited because they have no windows and are made completely out of masonry. It is a closed box which needs artificial lighting and mechanical ventilation all day long, resulting in high energy costs. The best way to limit these costs is to implement an active facade that controls the amount of daylight entering the building. After an analysis of existing active facades, the facades were differentiated into 5 types. The first type is called a collective facade. With this type, sunlight heats up the large mass of the facade, which is then slowly radiated into the building. Secondly, the exhaust air facade. Here, the cavity of the double skin facade is mechanically ventilated to prevent overheating. Third is the normal, passive double skin facade. The blocked sunlight is used to create a thermal buffer between the outer and inner climate. The fourth type is an active facade that incorporates shades that orient themselves to the position of the sun to control sunlight entry. The final type uses advanced materials that have sun blocking abilities that can be turned on or off according to the weather conditions. Based on this analysis, the following research question has been formulated. How to design a facade that uses the controllability over direct and indirect sunlight entry to decrease the energy load of the Rotterdam Maritime Museum. The following 3 references incorporate techniques that could accomplish such a facade. L'Institut du Mont Arabe has a south facade where the shading system is integrated. It is composed out of 2500 computed diaphragms of different sizes. This technique allows for the controlled variation of the size of the opening. The diaphragms are controlled by a program that evaluates sun brightness. With bright weather, the opening is kept rather small. With cloudy weather, it opens up. The double facade of the water cube in China is constructed out of 2 ETFE foil facades. The inner facade is incorporated with an adaptable solar shading technique. Changing the pressure inside these foil cushions creates an overlap of elements that block radiation. The double facade also works as a solar chimney and uses warmed up air to heat the interior. In the Chabot College, the glass itself acts like a shading system. Without any louvers or blinds, the view is unobstructed. The technology uses a coated glass of multiple layers. By running a small electric current through the glass, molecules move from one layer to another, giving the glass its tint. In contradiction to other types of glass, it has a range of transmission percentages. These three references form the starting point of our individual exploration of design solutions. Thanks for watching.